In this video, we are going to study what is the paraxial rays, what is the principal focus, what is the focal length and focal plane. So our first question is, what is the paraxial rays? So before that, you must know what is the constructions or how concave and convex mirror can be constructed. So we revise that one. This is the concave mirror. And this one is convex mirror. Now this one P, that is the pole of the mirror. C, that is center of the curvature. The line which can be passing through C and P, the line that is the passing through C and P, that is known as the principal axis. Okay, so you should remember this whole center of the curvature and principal axis. Then you can able to understand what is the paraxial rays. So now we define the paraxial rays. The paraxial rays are rays whose not parallel to principal axis, which are not parallel to principal axis, but which can make some small angle with principal axis. And these all rays are incident at very near to pole. These all rays are incident at very near to this pole and make some small angle with principal axis. You can see this one is paraxial rays. This angle is very small, so they can be reflected. Similarly, this is incident here also and make some small angle with this. So this is reflected angle. So these rays are paraxial rays, which incidents very close to this pole. Okay, this is very close to this pole. Because of that, this ray can make some angle with principal axis. Here you can see this is small, very small distance. Okay, so these rays can be incident very close to pole and make some small angle with principal axis. So those rays are known as the paraxial rays. So now we define what is the paraxial rays. So the definition is the paraxial rays, the rays which are incident and very close to pole and make small angle with principal axis, principal axis are called paraxial rays. Okay, so this is the definition of paraxial rays: the ray which are incident very close to pole and make small angle with principal axis. So that rays are known as the paraxial rays. Now second one, principal focus. So these topics we have discussed in the previous video and also we have studied in 10 standards. What is the principal focus, focal length and focal planes. Okay, so now we starting from what is the principal focus. So now we define the principal focus. We have write down this definition of paraxial ray. So now what is the principal focus? So when ray coming from infinite distance, so that rays consider as parallel to principal axis. So when the parallel rays are coming from infinite distance when incident on concave mirror, so after the reflection ray passing through a fixed point, or we can say that at one point on the principal axis, so that point is known as principal focus. We try to understand by using this diagram. You can see this is parallel ray. Now the center of the curvature, when draw a ray, or we can say that a line from center of the curvature to mirror, so that is the normal to the mirror. Please keep in your mind, whenever you draw a line, so this is normal to this surface. Whatever lines you can draw, these all are normals, because you can see this is the sphere, this is the part of the sphere. So whenever line from center to the circumference, that is the normal to the surface. So whenever you draw a line from center of the curvature to mirror, so that is normal to this surface. Okay, so now here we have considered this is the parallel ray coming from infinite distance. When incident on this mirror, so after the reflection, ray passing through this point. Consider one more ray, suppose this one. This is incident ray. So after the reflection, ray passing through this point. So all parallel rays are after the reflection are passing through one point on the principal axis. So this point is known as principal focus. So this is the principal focus and which is denoted by L. Okay. Similarly, you can see here where ray coming from infinite distance and parallel to principal axis. So after the reflection, ray can be reflected in this way. But when extended in back side, so they can be intersect at this point. Similarly, you can consider one more ray. So this is suppose this one. These are parallel to principal axis. So after the reflection, ray reflect in such a way it is appear to coming from a fixed point on the principal axis. So this point is principal focus. Okay, જ્યારે અહીંયાથી જોવામાં આવે તો આ રિફ્લેક્ટેડ રે છે એ કોઈ એક પોઈન્ટમાંથી આવતું હોય તેવું દેખાય. It is look like coming from one point on the principal axis when you look from here. Okay, so this point is principal focus for the convex mirror. This is for concave mirror. Okay, so define the principal focus. Then the parallel ray have two principal axes. When incident on mirror, on concave mirror, so after the reflection, reflected rays are passing through a point on principal axis. This point is called principal focus of concave. Okay, when parallel ray after the reflection passing through one point on the principal axis, so this point is principal focus. Similarly, you can write for the convex lens, the reflected ray are appear coming from one point on the principal axis. So this point is principal focus for convex lens, convex mirror. Okay, so you have write the definition for convex lens. Only difference is that the reflected ray here, this is same up to this one. The after the reflection, reflected ray are look like, or we can say that appear to coming from one point on the principal axis. So this point is known as principal focus for convex mirror. Okay, so this is the definition for principal focus. Now, what is the focal length? So we know that the distance of the principal focus from the pole, that is the focal length. Okay, similarly here, this is here. So focal length is the distance between pole and the principal focus. So this distance is known as the focal length. Okay, now next one, what is the focal length? So this is the important, and this is new for you because focal length is not studied in 10th standard. Now what is the focal length? Here we have considered only concave mirror. This is the concave mirror. This is the pole, center of the curvature, principal axis. This is the focal or principal focus. So now consider one plane which is passing through this focal. Consider this is the one plane which is passing through this principal focus. When paraxial ray Now we know that what is the paraxial rays? The ray which can make some angle with principal axis and it is very close to pole. So that rays or those rays are known as a paraxial rays. So now consider some paraxial rays. So we have considered one paraxial rays here. So after the reflection, this is make some angle theta. After the reflection, they passing through this. Consider one more ray which is incident at here. By making some incident angle with normal, this is the normal. You can see this is the normal. Normal to this surface by making some angle theta. So after the reflection, these rays also passing through this plane. So these two rays, this is first one and this is second, or we can say that this is first and this is second. These ray which is incident at pole, so after the reflection they reflect in this way. Similarly these ray by making some angle theta with this normal, then after the reflection these rays also passing through same point, same as to this previous way. So these point which is lies on this plane which is passing through principal focus, so this plane is known as the focal plane. Okay, once again I repeat, when paraxial rays are incident on mirror, so after the reflection these two rays, this is first one and this is the second ray, these both rays are passing through a same point and that point is lies on this plane. This plane is passing through principal focus, so this plane is known as focal plane. Okay, write down the definition. When the paraxial ray after the reflection passing through a point in a plane which is passing through principal focus. So this plane is called focal plane. What is the definition? When paraxial ray after the reflection passing through one point, but this point is like this plane and this plane is passing through principal focus. Because of that, this is the plane. This plane is known as focal plane. Okay, so you should remember this definition. This is asked in 2 mark question. Okay, first of all, paraxial ray, principal focus, focal length and focal plane. Now in next video, we derive the relationship between radius of the curvature, that is the distance between center of the curvature and pole. This is the R, and focal length L. Okay, that is the R is equal to L. So in next video, we derive this equation. Okay, so now we stop here. You should remember these definitions. Okay, thank you.